Beyond the familiar planets of our solar system lies a frozen frontier, teeming with mysterious bodies that challenge everything we thought we knew about the solar system's outer limits. These icy worlds, tucked away in the darkness past Neptune, hold secrets about the early days of our cosmic neighborhood, and even the origins of comets and icy debris that occasionally cross our path. Venture with me beyond the planets to explore these forgotten realms, where icy giants, dwarf planets, and dark, distant objects paint a picture of a cold, yet incredibly fascinating, frontier that could reshape what we understand about our place in the universe. The Kuiper Belt and the population of trans-Neptunian objects. Beyond Neptune's orbit, a vast, icy frontier stretches outward, populated by countless celestial bodies that have remained largely hidden from direct observation for centuries. This region is composed of trillions of small, frozen objects, collectively known as the Kuiper Belt, that form a sprawling, donut-shaped ring. Unlike the asteroid belt nestled between Mars and Jupiter, the Kuiper Belt extends hundreds of astronomical units from the Sun, capturing remnants from the solar system's formation era. These objects, called trans-Neptunian objects, TNOs, differ in composition, size, and orbit, offering clues about the early conditions that shaped our planetary neighborhood. The Kuiper Belt's objects are primarily made of icy substances, water, ammonia, methane, and rocky material, giving them a distinctive glacial appearance. Many of these bodies are just a few kilometers across, but some dwarf planets, such as Pluto, Haumea, and Makemake, tower over their smaller neighbors. Pluto, once considered the ninth planet, became one of the most famous TNOs after the New Horizons mission revealed its complex geology and icy surface. The presence of such diverse bodies demonstrates the dynamic history of the Kuiper Belt, which has experienced little significant collisional disruption in the eons since its formation, preserving primordial material. This population of trans-Neptunian bodies offers an invaluable window into the solar system's ancient past. Their orbits are often highly elliptical and tilted, hinting at gravitational influences from the giant planets and possibly unseen massive objects, like the hypothesized Planet 9. Studying these orbits helps scientists refine models of planetary migration and the early dynamic upheavals that shaped the current arrangement. Moreover, the compositional diversity among TNOs suggests a complex chemical history, with some objects displaying signs of cryovolcanism or resurfacing events driven by internal heating or radiation. These bodies challenge us to understand the delicate balance between formation, evolution, and current stability in the distant reaches of our system. Exploring these icy worlds is no small feat. Deep space probes have only just begun to scratch the surface of this cold, mysterious realm. Missions like New Horizons have ventured beyond Pluto, revealing rugged, cratered surfaces and layered ice deposits, while telescopic surveys continue to discover new objects lurking in the shadows of the Kuiper Belt. Each new find adds a piece to the puzzle of how the solar system evolved and interacts with the wider galaxy. In essence, the Kuiper Belt and its population of TNOs serve as frozen relics, delicate memories of a formative epoch, hidden far away at the edge of the known universe, waiting to tell their stories. Dwarf planets and notable bodies beyond Neptune. Beyond Neptune's orbit lies a cold, mysterious region populated by a variety of small, icy worlds that challenge our understanding of the solar system's architecture. Among these are dwarf planets, which are similar in composition to major planets, but lack the mass to clear their orbital neighborhoods. Pluto, the most famous of these, dominates this realm, but it is by no means alone. Alongside it orbit several other noteworthy bodies such as Haumea, Makemake, and Sedna, each with unique characteristics that intrigue astronomers and planetary scientists. These bodies often exhibit complex surface features, unusual shapes, and orbital behaviors that defy simple classification. Apart from recognized dwarf planets, this distant zone contains numerous smaller objects, remnants of the early solar system. Many are part of the scattered disk, a population of icy bodies with highly eccentric orbits reaching far beyond Neptune. These objects can have elongated, inclined orbits, hinting at gravitational influences from unseen bodies or even the hypothesized Planet 9. Some of these bodies, like Quaoar and Orcus, are sizable and have surface compositions rich in ices and organic molecules, giving them a striking appearance under distant observation. The diversity among these bodies suggests they originated in distinct regions and were later scattered across the outer reaches by gravitational interactions. The Kuiper Belt, a disk-like region extending roughly from 30 to 50 astronomical units, hosts the majority of these objects. It serves as a sort of transitional zone between the asteroid belt and the distant realm of scattered disk objects. Many Kuiper Belt objects, KBOs, share similar features, including icy, cratered surfaces and irregular shapes, though some like Varina or 20,000 Varina show elongated forms, indicative of a history involving collisions or accretion. The discovery of these bodies has transformed our view of the solar system's boundary and hinted at the potential existence of even more distant worlds awaiting discovery further out in the realm of the hypothesized Oort cloud. These distant bodies are not just frozen remnants. They are time capsules carrying clues about the early solar system formation. Studying their orbits, compositions, and physical properties helps astronomers piece together the complex history of planetary migration and gravitational interactions that shaped our celestial neighborhood. In recent years, advances in telescope technology and space missions are bringing these hidden worlds increasingly into focus, with some speculating about the presence of unknown planetary bodies lurking in the dark outskirts beyond what we currently observe. Each new discovery enhances the ongoing narrative of a solar system that remains full of frozen, forgotten bodies at the very edge of exploration. The discovery and significance of Sedna and other aligned bodies. Sedna, a distant and mysterious object, stands as one of the most intriguing discoveries in our ongoing quest to understand the outer reaches of the solar system. Its elongated and highly inclined orbit stretches far beyond Neptune, taking it into the realm of the hypothetical inner Oort cloud. Unlike classical Kuiper Belt objects, Sedna's orbit is so elongated that it takes thousands of years to complete a single revolution around the Sun. This unusual orbital behavior hints at a past that may involve gravitational nudges from unseen or now distant bodies, or even the influence of passing stars, suggesting that Sedna's origins are linked to processes far more complex than typical trans-Neptunian objects. What makes Sedna especially significant is its size and composition. Estimated to be hundreds of kilometers across, it has a reddish hue that indicates the presence of complex organic compounds on its surface, formed and preserved through its cold, distant environment. Its discovery opened new doors to understanding the diversity of objects that exist beyond Neptune, objects that challenge traditional models of the solar system's formation. Sedna's orbit is a bridge between the Kuiper Belt and the hypothesized inner Oort cloud, raising questions about how such bodies were captured or formed in this remote zone. This has implications not only for planetary science, but also for understanding the dynamic history of our stellar neighborhood. Beyond Sedna itself, astronomers have identified a growing population of aligned bodies, objects with similar orbital characteristics, such as high inclinations and elongated paths, that appear to cluster in certain regions of the outer solar system. These bodies exhibit a shared orbital plane or similar perihelion distances, hinting at a common driver behind their trajectories. The existence of these clusters has fueled multiple hypotheses, including the potential presence of an unseen massive planet, sometimes dubbed Planet 9, exerting gravitational influence on these distant objects. This hypothetical planet could be shepherding these bodies into their current configurations, a notion that excites many in the scientific community because it points to a hidden piece of the solar system puzzle. Studying Sedna and its aligned counterparts offers a glimpse into an era of the solar system's evolution that is largely hidden from view. These objects act as cosmic relics, preserving clues about gravitational interactions in the early solar system or even the influence of passing stars and molecular clouds. Their distant orbits and peculiar alignments challenge existing models, pushing astronomers to reconsider how planetary systems might form and evolve over billions of years. In essence, Sedna and its kin are not just isolated oddities, but key pieces of a much larger story about our celestial neighborhood's history, and perhaps its future. The future of exploration of the outer solar system. The outer reaches of our solar system are beginning to unveil their secrets, driven by advancements in space technology and renewed interest in exploring the distant, icy worlds beyond Neptune. Missions like the New Horizons probe have already provided astonishing insights into objects such as Pluto, and recent visits to the Kuiper Belt have revealed an array of small, primitive bodies composed mostly of ice and rock. These worlds hold clues about the early solar system, preserving pristine material that is billions of years old. As scientists turn their gaze outward, the focus shifts toward understanding these icy remnants and what they tell us about planetary formation and the distribution of matter in the solar nebula. Looking ahead, the future of exploration in this cold frontier promises exciting possibilities. Next-generation spacecraft, equipped with more sensitive instruments and longer-lasting power sources, aim to reach even more distant objects. Missions like the proposed Dragonfly or Advanced Orbiter concepts could delve into the atmospheres, surface compositions, and potential subsurface oceans of their targets. Covering long-distance travel, these missions will need to overcome significant hurdles such as intense radiation belts and extreme cold. But technological innovations, such as nuclear-powered engines, offer promising solutions. The goal is to closely study objects like the frigid moons of the scattered disk and the enigmatic detached objects, to understand how they have evolved over billions of years. Furthermore, an emphasis on automation and robotic exploration is likely to transform our approach to the outer solar system. Since human missions face extraordinary challenges, extreme distances, and prolonged communication delays, autonomous landers and orbiters will play a key role. These robotic explorers could perform detailed surface analysis, drill into icy crusts, and even search for signs of subsurface liquid water, which remains one of the most tantalizing aspects of these worlds. Innovations in artificial intelligence are expected to boost the capabilities of these robots, making them more self-reliant and capable of conducting complex scientific experiments independently. As these missions become more sophisticated, they will generate a wealth of data, gradually unveiling the secrets of the distant, frozen worlds. Looking even further, some scientists entertain the idea of deploying cryobots, robots designed to melt through thick ice layers, to reach hidden subsurface oceans on moons like Europa, Enceladus, or even distant Kuiper Belt objects. These environments could harbor microbial life, making their exploration a top priority in astrobiology. The long-term vision involves not just robotic exploration, but potentially sending crewed missions to the outer solar system, though that remains a distant goal. Continuous development of propulsion technology, habitat shielding, and life support systems are essential if humanity hopes to venture into these icy frontiers. Ultimately, the outer solar system may reveal itself as a pioneering ground for understanding planetary diversity, the potential for life beyond Earth, and the very history of our cosmic neighborhood. Usnovnoy, Rusgil 5. Beyond the orbit of Neptune lies a vast, cold expanse filled with mysterious objects that challenge our understanding of the solar system's boundaries. Among these are the so-called forgotten bodies, icy worlds that drift in the distant reaches of the Kuiper Belt and the scattered disk. These objects often have highly elongated orbits, taking them hundreds of astronomical units from the Sun at their furthest points. Their surfaces are predominantly composed of frozen volatiles like methane, nitrogen, and water ice, reflecting a faint glimmer of sunlight and embodying a frozen archetype of planetary formation. Objects such as Quasar, Sedna, and Eris serve as prime examples of what lies beyond Neptune. Sedna, in particular, has an orbit that extends over 900 astronomical units from the Sun, an astonishing distance considering Mercury's orbit is only about 0.39 AU. Its surface appears reddish, hinting at complex organic molecules called tholins, created by the irradiation of ices on its surface. These distant bodies, often called detached objects, are thought to have been nudged into their current orbits by gravitational interactions with either passing stars or yet-to-be-discovered distant planetary bodies. Their origins remain a puzzle, with some theories suggesting they are remnants from the early days of the solar system, preserved in cold storage. The study of these bodies has grown increasingly important as they hold clues about the primordial materials that formed the solar system. They preserve a record of the early solar nebula, untouched by the more active processes occurring nearer to the Sun. Their highly inclined and eccentric orbits provide insight into the dynamical evolution that shaped the Kuiper Belt and outer scattered disk. Missions like New Horizons, which flybys objects like Eris, previously known as Ultima Thule, have started to unveil the complex geology and composition of these distant worlds, revealing surfaces layered with ices and sometimes surprisingly diverse terrains. Despite their importance, many of these objects remain undiscovered due to their extreme distances and faint brightness. Advances in telescopes, particularly the development of large aperture observatories and more sensitive detectors, have made it increasingly feasible to identify and track these bodies. Researchers expect that future surveys will considerably expand our catalog of the solar system's most remote members, promising new insights into planetary formation, celestial mechanics, and the broader architecture of our cosmic neighborhood. Exploring these frozen worlds beyond Neptune continues to be a frontier, blending cutting-edge technology with fundamental questions about the origins of our planetary system. As we peer into the dark, icy reaches beyond Neptune, we've uncovered a realm filled with mysterious, frozen worlds that challenge our understanding of the solar system. From the enigmatic Kuiper Belt to the distant, icy inhabitants like Sedna and Kuiper, these forgotten bodies offer clues about the origins and evolution of our celestial neighborhood. Their extreme cold and distance remind us how much remains to be explored and understood beyond the familiar planets. Thanks for joining me on this cold and fascinating journey to the edges of our solar family. It's incredible to think about what might still be out there, waiting to be discovered. If you're as captivated as first and by these icy worlds, make sure to stay tuned. There's plenty more cosmic secrets and future missions on the horizon that will bring us even closer to understanding these distant, frozen realms. Until then, keep looking up and dreaming big. There's a universe of mysteries still waiting just beyond the known.